Hey folks, today we're going to take a look at kinematics, and that is the motion of objects typically under the influence of gravitation, but not necessarily. Could be out in space. And one of the first things that we're going to look at is going to be the concept of displacement. And what I do is I use X or Y for position, X or Y for position. So a displacement is going to be equal to, let's say, Y2 minus Y1. Position 2 minus Y1, that's displacement. And this should be differentiated from distance because displacement is a vector quantity. What that means is that if you were to go 4 meters to the right and 3 meters upward, then your displacement would be here, and that would be 5 meters, whereas the distance you would be traveling would be 7. So that's the difference. Displacement is a vector quantity. Then what we have is we have velocity. Now with velocity, what happens is you're taking a look at the displacement and you're dividing it by time. So you may define velocity as y2 minus y1 over t2 minus t1. And one way of looking at this is that it's a slope. So right over here, what we see is we see the meters and we see the seconds. That's displacement, the unit of displacement, and that's the unit of time. And the slope is the change over the change, which is this. So this slope is the velocity. And we can have something very similar to this by looking at the change in velocity over the change in time. And that's equal to the average acceleration, v2 minus v1 over t2 minus t1. So what happens here is that when we have a slope like this, or we have a slope like this, the change in velocity over the change in time, that will give us either the velocity, the rate of change, displacement over time, or acceleration is the rate of the change of the velocity over time. So we'll look at some of these later, but that's the general idea. Now, what happens is if we take an object, and that object is going to be, let's say, under Earth's gravity, we'll just say it's 10 meters per second squared. What this means is, it means that there's going to be a change in the velocity because this is acceleration. It has the units of acceleration, meters per second squared. And this means we're going to have a change in velocity over change in time. That's what acceleration is. So that means we're going to have a change of meters per second every second. So if we drop this object, we could use math to do this, but we don't need to in this case. What's going to happen is it's going to start out with a velocity of 0. And then after a 1 second interval, it's now going to be moving downward at 10 meters per second. And then it'll be moving at 20 meters per second, etc. So that's what acceleration is. It's a change in velocity with respect to time. Now, when we do this kind of mathematics, we don't have to, but it's a good idea to kind of follow a rule. And that is that when things are moving down, we'll make them negative. And when the things are moving to the left, we'll make them negative. And when things are moving up or to the right, we'll make them positive. And that's going to apply to everything. That's going to apply to displacement and velocity and acceleration. The only problem is on the MCAT, as far as the acceleration due to gravity, they may give it as 10 meters per second squared, and you need to make it negative. They won't do it for you. So that's a given. That's not a problem. Just remember to do it. And there are some equations where you got to keep it as positive. And I'm sorry about that, but you just memorize those equations and you'll be all set. So the thing is that how can we do stuff like this mathematically? So here's what happens when we want to do calculations mathematically. There are 5 kinematic equations, and each kinematic equation has 4 variables. One is unknown, the other 3 are known. And in order to decide which equation to use, you make a list. And when you make that list, you look at the variable that isn't present, and that tells you which equation to use. So let's go ahead and imagine that we have a situation, just like what we've done here. We have a rock, no air resistance, G is equal to 10 meters per second squared. And we're going to take that rock at T is going to be equal to 0 like this. And we're going to drop that rock. And we're going to say, I wonder how far it gets. So we'll say, what is Y going to be, the displacement over here? And let's say this would be T1. And then over here, we'll say T2. That's going to be, let's say, 4 seconds. So the duration is 4 seconds. This 0 doesn't really matter here, but it might be included in the problem. So I want to put it there so it doesn't confuse you. So here are our variables. We have over here Y, V1, the initial velocity, V2, we have A, and we have T. So the question is going to be right over here. That is the displacement. Downward, we know it's going down. And it's starting at rest, so this will be 0. And the final velocity is not asked about. We don't care what it is. So this is the variable that will tell us which equation to use. The acceleration is going to be -10, minus because it's going downward. And the value for T, the final value for T, is going to be 4. So this will be a nice plug-in. And what will happen is we'll come over here and we'll say no V2. That tells us which equation we're going to use. And then we just say we've got Y is going to be equal to V1T, and that'll be plus 1/2 A T squared. And the value that we see over here will be 0 because this is 0 right over there. And we're looking for Y right there. So this will be -5. That's the 1/2 T squared. And that will give you the answer. Now, obviously, you're going to have a square root in there. You can work it out. They probably won't give you bad numbers because on the MCAT, they don't do that anymore. They just give you nice, pretty numbers, and I'm just making this up. So, but basically, that's the idea. And you can do it for all of these the same way. So the next question is, what happens if we have things going in 2 dimensions? This is a pretty straightforward situation. So let's say that we have a vector here, and then this velocity, we're going to say, is going to be 20 meters per second. And then right over here, we're going to go ahead and draw a horizontal line, and we'll say that this will be 30 degrees. And we can ask a whole bunch of questions about this. But the main thing is, the first thing to do is to break it down. And when you break it down, you want to break it down into components. So what we're going to do is, we're going to say that this is the hypotenuse right over here. And then over here, there's our angle of 30. And then on this bottom part here, we're going to call that adjacent to the angle. And on this top part over here, we're going to call this opposite to the angle. And what that does is it gives us this. We have sine of the angle is going to equal opposite over the hypotenuse. We have cosine of the angle is going to equal adjacent to the hypotenuse. And we have tangent of theta is going to be equal to opposite over adjacent. You don't need the other 3 trigonometric functions. So what you can do with this is you can break it down. And if you use this and break it down correctly, what you end up over here is this is going to be 20 sine of 30. And by the way, you should know that sine of 30 is a half, but they usually give that to you. And then what happens over here, this is going to be, if you break it down correctly, 20 cosine of 30. Now, what this does is it gives you the velocity initial in the y direction, and it gives you the velocity initial in the x direction. And what happens with this is it allows you to do all sorts of cool calculations. Because what will happen is these will be independent of each other. In the vertical direction will be acceleration. These equations right over here, they all involve acceleration. But when there's no acceleration, we end up with this equation here. And that is the velocity, average velocity times time is going to equal the displacement. A very simple equation. Sometimes for memorization purposes, I call it x is equal to TV. So what that means is we can do any calculation we'd like with acceleration using this. And as far as this goes, it's not going to have a velocity which changes because in the horizontal direction, gravity doesn't act. So whatever the heck 20 cosine 30 is, whatever that is going to be constant. So let's take a look. Let's take a look at what this would appear to be like. What would happen with this, and let me just take a look at the numbers. Yeah, it'll look like this. So this is going to be a parabola. So parabolic shapes always form with kinematics. And what will happen is the x component is going to be constant throughout. It's going to look like this because there's no acceleration. But the y component is going to act just like what we saw over here, except it's going to start going upwards, and then it's going to end up at 0 position, and then it's going to go downwards. So it's going to go up, and it's going to go down by changing 10 meters per second squared after each second. And you can calculate it. So when you go ahead and you do that calculation, you're going to end up with something like this. You're going to end up with it going very quickly, less, 0, down like this, and then down over here like that. So these are the vectors in the y and the x that cause this parabolic shape. And you can solve for lots of things in this parabolic shape. And one of those, using these equations, so they're all the same, but you should actually practice doing them. And one of these is called the range equation. And they probably won't ask you to plug it in, but they might ask you a question about the range equation. So here it is. Range is the distance that the object is going to travel. So that's going to be our range like that. And it's equal to v squared over g in absolute values, sine. Yeah, there's ways they could ask this. And then 2 theta. So if we think about what's going to happen is, and I'm not going to explain it too much, but what happens is when this is 45 degrees, the range will be at a maximum. And obviously, as we increase v, the range will increase. And as we increase g, the range will decrease. But the thing to understand is that if we fire something off at a 45-degree angle, it's an optimum situation between hang time, how long it's in the air, and the forward velocity. So what happens is we have maximum range at 45 degrees. But then if we go to 60 degrees over here, or we go over here to 30 degrees, what will happen is the range will decrease. And the reason for this is that at 60 degrees, it will be in the air longer, but it won't get as far. And at 30 degrees, it will be in the air shorter, but it'll be going faster, but it's not going to be optimum. So that's going to be optimum. And you can do this calculation with the range equation. They could give you nice numbers, actually, so they could ask it. Or you can use any of these equations that we have up over, well, they're over here. Any of these equations up over here. Now, there's a couple of interesting things you need to know before I kind of run through this part over here. One of the things that is interesting to know is how time is related between X and Y. So there's a standard question where you have an airplane like this, and the airplane is going to be a certain distance from the ground. Let's just make it up. Let's say 1,000 meters here. And what's going to happen is we're going to have some people that are camping out here, or they're refugees or some story like that. And what we need to do is we need to get an object to land right over here. And the plane is moving at 500 meters per second. And so we want to know this distance here. We want to know when to drop the supplies so they land right over here. So the way this works, and it works for almost all the problems, is first, what you do is you're going to use the vertical component to get time. And once you do that, then you're going to use time to get the answer. So let's go ahead and use these equations to see how we would do it. So what I'll do is I'll come over here and I'll say we have Y, we have V1, V2, we have A, and we have T. Okay, so Y is minus 1,000. And then our value for V1, by the way, everything I'm doing here is vertical. So the plane has a velocity, but its vertical velocity is 0. That's important. See what I'm doing here? It's vertical. We must treat these independent of each other. We'll deal with the horizontal velocity in the second step. So, and what I sometimes do is I use Y for vertical and X for horizontal if I want to remind myself. I don't always do that. Okay, so what we have here is 0. And then what we have over here is the velocity isn't going to change, but we'll just leave it like that. The acceleration is going to be, oh, I'm sorry. The velocity isn't going to change, not of the plane. But what's going to happen is the object is going to drop. So the V2 is going to represent the object here. So let me just make sure I explain this correctly. The plane has no vertical velocity. That's why it's 0. It will have a vertical velocity when it basically drops our package. So this 0 represents 0 vertical velocity of the package. 0 vertical velocity of the package. This represents the final vertical velocity. So I end up using the same equation I did before. This over here is minus 10, like this. And then what's going to happen is we're going to solve for t. Okay, so it's a similar equation. We're going to look for no V2, and that'll give us y is equal to V1t plus 1/2 AT squared. Now, here's an interesting thing. There are ways to avoid the quadratic equation, but it probably won't occur on the MCAT. But on this equation here, if you've got a term for V1 here, and you've got a term for acceleration, then you're going to use the quadratic equation. So you want to avoid that. And there are ways to do that. You can break up the problem. But it's not likely to be on the MCAT, really. I'm not going to go into that. But if you're taking a physics course, it's very useful if you don't like the quadratic. Okay, so what happens over here is we basically, this is going to be 0. We have all the other factors here, and we basically solve for t. So once we solve for t, then what we do is we just use x. I'm going to use x is equal to t times v. X is going to equal t times v. So we have our value for t. And our value for X is going to be what we got over here. Let's see. Oh, okay. Yeah, here it is. I didn't know what I did with it. 500 meters per second. So this will be 500 meters per second. So what happens is the seconds, whatever that is, cancels, and then that gives you the answer. So the thing about this is that in a whole bunch of the harder problems, which are not that hard, you first solve for t where there is acceleration, and then you use t in the second part where there isn't to come up with an answer. Now, one other thing is shooting at a monkey. I don't know why they want to shoot at monkeys, but that's very popular. So what we have is we have a monkey in a tree like this, and then we have someone with a rifle. And well, what they do is they shoot at the monkey, and they shoot directly at the monkey. And the monkey doesn't hear them, it sees them. So it's immediate. The monkey lets go of the tree and starts to fall, and the bullet is shot, it also starts to fall. And it turns out that because acceleration is constant at 10 meters per second squared, we'll make it negative, the bullet and the monkey are going to fall by the same amount. It doesn't matter that this is at an angle. If this is lined up, they both fall by the same amount. And unfortunately for the monkey gets struck by the bullet. Okay, but the principle here is it doesn't matter how you aim the rifle, if you aim it straight up or even straight down. If you just look at the situation of it falling as a free falling object, it will fall by the same amount, even if it doesn't seem logical. Okay, so let's take a look at this. We're going to wrap this up. And obviously doing a number of problems on your own is useful. But what we have over here is we're looking for the velocity. And so the change in displacement in meters here is 4. And the change in time over here is 4. So in this case, the velocity is 1 meter per second. And that's pretty much the whole deal. If we're looking here for the acceleration, it's the same idea. What we have is a change in velocity over the change in time. So the change in velocity is 4 and the time is 4. So that will be an acceleration of 1. Now, you might ask, well, what happens if we want to look at the area under the curve? So it's not the slope, it's the area under the curve. This is the stuff that Newton worked on with calculus and figured out how to do it for all sorts of weird shapes. But what happens with this is if we multiply meters per second by seconds, that will give us the area under the curve. And that's going to give us, seconds cancel, the displacement. So you could also get the displacement from this by doing this multiplication. These are pretty easy. What's the velocity over here? Well, the velocity is constant. The velocity is going to be 2 meters per second. And here the acceleration, 2 meters per second. These aren't connected, of course. And finally, and this is that concept of using the area here. Now here I use the area with a slope that was greater than 0. Here I'm using the slope that's flatline, but it doesn't matter. It's the area under the curve that gives you the displacement because the seconds here cancel with this, and that gives you the displacement. And what happens with something like this is these values actually can be the same if they're correctly oriented. I think they are here, but that's beyond the situation. So that's a brief discussion of kinematics. I hope you liked it. Thanks for watching, folks.